Yeah, g'day and welcome back to the channel. I'm working on bringing this beautiful old Schaublin 125 CNC lathe back into service. Been pulling it down, cleaning it, and also it's going to get a new controller. But the focus this week is going to be its pneumatic system. The big question is, can I compress all of this down into about this area here? Because that would be awesome. Let's have a look. Since my last video, I've been degunking the motor enclosure, digging all this out. It's pretty gross. I've also put a fair bit of work into planning the retrofit and started ordering some parts, so hopefully some of the new bits will be coming in this week. I don't really know much, I don't really know anything about pneumatics. I think back in my apprenticeship, back in '89, we did do a module on pneumatics, and in the trade school we had these old de Havilland Devon aircraft which had pneumatic brakes and flaps. So we definitely did some module on it, but I really don't remember any of it. So let's take a look at this pneumatic system. What do we got? We start off down here with just a normal inlet pipe from the shop air. Air gets filtered, drops its water here, and this is the main shut-off valve for the pneumatic. From there, it goes into this divider block, which also has a pressure switch on it to feed back the pneumatic state to the controller. Air divides here between the two surfaces. So this air, which stays dry, goes out through a pressure regulator through this control valve and controls the collet closer. It's the only surface which uses dry air. The flow through this bottom system gets lubricated, and then that lubricated oil comes up to this manifold at the top, up here, and then nearly all the other surfaces run off that manifold. So these first two valves on the manifold control the back gear, so giving it either 1-to-1 speeds or a speed reduction of 6.5-to-1. This next valve controls the coolant flow. Basically, this machine runs a little three-phase pump in the coolant tank, and that should run all the time. And then you just control the actual flow to the nozzle with a pneumatic valve. Not 100% sure if I like that plan, but I'll probably implement it anyway. It's original. This next valve is the switching of the automatic tool changer. I believe this was blanked. I'm not sure they had a fifth one on there. It looks like it's just a spare. And then this last valve here, which takes air off the end of the manifold. This one is used for controlling the tailstock, clamping or unclamping. What am I trying to do? My problem with it is just too bulky. I really want to use a significant part of this space for electronic. I really need to try and compress all of this down as small as I can get it. The bottom half here is mostly just preparation of the air, and there's really no need for that to be inside the machine. So what I think I'll do is make like a prepared air module on the wall with the filtration, the flow divider, the regulators, and the oiler. So if I can get all of this air preparation out of the machine, the actual valving and its electrical control can also be significantly reduced in size with modern components. So I'd like to bring them down to the bottom here and leave me space above there for my variable frequency drive and my main motor drivers. Let's see if it works out. Oh good, the first of my ordered parts have arrived. Spent most of last week researching a few different areas and ordering a few parts for the Schaublin project. Aha. So this is a VFD. This is a Lenser 8215. Came with the control panel for programming it. Lenser is generally a very high quality manufacturer, so I got it for a really good price used over Wilharden. Better connect it up and just see if it turns on and see if it works. It's designed for 3 kilowatt motors, which is the same as the Schaublin has. I'll just wire it up and test it. This is not how I'll connect the earth once I put it in the cabinet, but just for turning it on and testing it should be fine. Well, that's a good start. It powers up. There's a flashing green light here above the control module. Yeah, it's definitely doing something. Oh yeah, it's reacting to input commands. It was delivered with a manual, so I'll have to go through, set all the motor parameters into it and connect up the motor and give it a test. I'm assuming at this stage it's working. Yeah, my jalapenos are coming along nicely. I've already harvested some of the green ones to pickle, but I also want a bunch of them to turn red so I can smoke them and make chipotles. Cool, got a package. Alright, this is a replacement. I've been using them for about a year and I really like them, but the receiver, the output jack died last week. So did a warranty claim on it, they've replaced it free of charge, so that's good. Yeah, this system works really well for me because most of the vlogger style microphones are designed for someone standing in front of the camera. The way I do my channel, I'm normally standing behind it. It's also one of the rare products made in Australia, so good on you guys. I think I know what this is. Came in from Portugal. Yep. It's a set of Mesa control cards. To control the Schaublin, I'm doing a collection of 5 cards. Their stuff is just rock solid. You can do pretty much anything with Schaublin CNC and Mesa cards. Like I've been using it to control my miniature soccer table.
Today I got mail from Mark. That looks cheesy. And it's my back lathe. Looks nice. The next few minutes will show if I will have to order a new one or not. Cool. Very nice. Well, I won't turn this down because I need them, but I'll just make another one, which is thinner, and for now I will just use a bolt. And it does. Mark, thank you. Great job.
Since the modified backing plate fits, I can go ahead and modify the chuck next. Since I already showed all the setup work last week, I won't bother repeating it all this week. Well, that went really fast. If I didn't know better, I'd almost think that CNC was designed to speed up repetitive work. Cool, another job done. Hopefully with this I can motivate Sergey to reprogram the gearbox on the Maho.
4 to 6 days later.
Cool, today even better, 2 boxes. Let's have a look. I hate that packing foam stuff, it drives me nuts, it goes everywhere. Alright, here we go. I didn't realize these things were so tiny. Better zoom in. What are these things? Well, they're kind of like Lego for process engineers. Each of these is a pneumatic valve, but in the module you've got the control at the top, electrical control, and then you've got all of your connectors out the bottom and your supply to the sides. This one has got a blocker in the middle, so it divides the thing into 2 separate systems, so you can have 2 different kinds of air, and I need that because I need both lubricated air and unlubricated air. So I needed this one. There's a variety of different types of valves. I've got J and M's in this one. So I bought this one because I needed all the fittings to come in from 2 sides. I needed a blocking plate, and it's also got all of the fittings for the piping out to the services. The problem is this one uses the Profibus, which is a serial connection standard. It's probably possible to command Profibus through Linux CNC, but you know, you need to know what you're doing, and I really don't. So I bought a second one. I mean, it only costs $60 extra to buy a second one, and I'm sure just buying a couple of parts for these would cost way more than that. But this one has got a different top on it. Each one of these pins controls 1/2 of one of these valves, so I can just connect this up directly to a Mesa card and just drive this directly. Next thing to do is pull this all apart, play Lego with it, and put it back together in a configuration that'll work for my machine. This stuff's just quick disconnect. You push down on the blue and pull out the pipe. I'll be able to reuse those tags. They're only held on by tie wraps. That's quite handy. Here you can see the electrical terminals on the end of each of the valve blocks. They just stick into the control module. So I'll pull the plugs too, just so they don't get damaged. Now I'm guessing when I take out those 2 long bolts, the whole stack just falls apart. Let's give that a go. Yep, another one at the top. So, end plate. Oh, there's this foam seal, I guess I want to try and get that off without damaging it. And then individual valves. What a really cool system. So this is that blanking plate, separates it into 2 flows. I wonder if you're supposed to replace the seal when you replace a module. I would think so. Well, that was fun. Let's do the second one. Fun story about pneumatics. When I was in that training school, I remember there was some time that they needed one of those de Havilland Devons taxied. And of course, they didn't let us taxi the aircraft, so they had to get a pilot over from the local squadron. And this guy, of course, he was flying Cessnas or something, so the Cessna Golden Eagles, so he didn't have much clue. Yeah. He obviously didn't know that the brakes were pneumatic, because as soon as the engine started, he gave the signal for chocks out, thinking he had the brakes set, but nope, there was no pneumatic pressure to hold the brakes on, and he ran the plane straight through the battery cart, chopping it up with his propeller. Oops. Okay, it looks like this one is newer or hasn't done as much work. It's coming apart much more easily. Also, there was no corrosion on the screws like on the first one, so I'll try and reuse as much of this one as I can. Well, it looks like I've got a pretty good assortment. In this CPV-10 system, Festo offers a number of different valve modules with different functions, and they're designated by these codes. Now in this case, I'm going to need to go through and look at each individual valve from the Schaublin and then try and work out what the replacement valve is going to be. So therefore what letter I need to install in that location. As I said, Lego for process engineers. Cool stuff. So if we look at the valves used here, the shutoff valve is just a simple two-position, I think it's called a 2/2 valve. This one needs to be able to reverse the flow from left to right. It also needs to latch in whatever position it's in. But I looked here at the Festo manual and they don't actually offer 4-2 valve modules. However, they do have 5-2. The only difference is that these ones don't return the exhaust flow to the same port. One is always the inlet port, so you can see in this position air would go in through the inlet, come out at 2, and then the exhaust air would come down at 4 and or exhaust at 5. But when you shove the valve over to the other side, it'll go in at 1, out to 4, come back down through 2 and exhaust through 3. So 3 and 5 are the two exhaust ports. Having two separate exhaust ports, 3 and 5, out of a valve doesn't matter because the end plates manifold those back together. Here to here are joined to a single exhaust anyway. Does one of these with the pilot air to both sides of it latch where it's left? If someone got experience with this, I'd really appreciate our feedback in the comment section of what I should be using there. So let's start building that up. The first thing we have is an end plate, then my J valve, which will be used for the dry air for the collet closer. Next up, I'm going to need the separation plate, the T, and if all of the other valves will be supplied by the other end. Other valves, I think, are all the same, all 4 of them. All they need to do is direct the flow of air to either one side or the other, and then vent overboard. These two are really connected together because, of course, they work as a team. Now, in Festo's CPV system, they pack 3-2 valves as pairs, which kind of makes sense for what we're trying to do here. So looking here at the back gear, what have I got? I've got 2 solenoids, and in the resting position, one of them's open and one of them's closed to incoming air. Yeah, both closed. The N has both open, so I need an H by the looks of it. So that has one closed and one open. I don't have an H. Another question for those experienced at this stuff, are these valves two completely electrically and pneumatically separate valves? Or are these on a single spool and therefore what happens to one happens to the other? I'm just going to assume that an N will do the job at this stage, mainly because I've got one of them. So I'll put an N over here, and that's going to be the back gear. Yeah, so if that works, and I just add power on, energize one and leave the other de-energized, then it's kind of the same as what I've already got. And then when I want to change gear, I just have to switch which one's energized. And that's pretty easy to do in Linux CNC. If those two valves are connected on a spool, that ain't going to work. If I do have to do this with an H, is there anyone out there who happens to have an H sitting around they'd like to sell me? Right, moving to the next system. This one's easy. This is just the coolant misting system. And here we want a normally off 3-2 valve. Looking in the catalog, normally off 3-2 is a type C. And we'll just use 1/2 of that. That's easy, I've got plenty of those, I think. Well, I've got 2 of them. So there's my type C for the coolant. Moving to the next system, this is the tool changer. So it's also just one 3x2 valve, so once again I'll use 1/2 of a C. And the last valve I need is another one of those 5x3 valve, which stays in wherever position it's left. And that was the same as the collet closer, so that's another J. And I don't have another J. If there's anyone out there that's got a CPV10, a J and an H sitting in a box somewhere that they'd like to sell me, please contact me through the comment section or drop me an email through my addresses down in the about on this channel. Since I don't have a second J, I'll just simulate that one for now with an M, which is also a 5x3 valve. Okay, so that gives me 1, 2, 3, 4, 5, 6. I need 2 spaces, but I've only got one, so I really need a second one of them. But I'll throw in an N for that. That's really not a good choice because that's a normally open valve, so it'll blow air out the entire time. I guess the other option is just putting blanks in the bottom of this would also do the same thing. These little blue switches on the front allow you to manually set a valve position. That's probably pretty handy for troubleshooting, I'd say, and also for setup. Another thing I like about this Festo system is that these right angle fittings actually have freedom of rotation, so you can sort of line them up where you need them. Next comes the electrical control. Well, after all that, if I understand it correctly, I'm missing one H, one J, and one L. So can I do what I set out to do? If I move the preparation of air out of the machine, can I get all of this down into this location? Sure can. This is looking good. I'm still going to need to buy a bunch of tubing to redo all of the pneumatic hoses on the machine and a bunch of end fittings to connect into the various different components, because this Festo system is totally different to what Schaublin originally used, but that's all part of the fun. Well, if you've made it all the way to the end, thanks a lot for watching, and I'll see you next time.